This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Hello and welcome to another episode of Design Safe Radio. I'm really excited to be with you today and talking with Reid Zimmerman, who is a practicing engineer out in the world. So it's good to be able to talk with another practitioner, although we love talking with our scientists who got their fancy PhDs and the right papers for people that we hope they read. It's really nice to be able to talk to somebody who's out in the world, bringing forth the effects of that research into practice, out into the real world in ways that we can see it. So, Reid, thanks for joining me today. Good to see you.
Good to see you too, Dan. Yeah, thanks for having me.
What I find really interesting about the intersection of science and engineering, which is the playground that you and I live in, is how do we actually get this research that's so important, and we're spending all sorts of time, energy, money, effort to produce this research. But then we need to actually apply it to our everyday lives somehow. So what is the role of an engineering practitioner like yourself in a research project like Tallwood, the one that we've been talking about for weeks? If you haven't listened to our series with Dr. Kerry Ryan and Jeff Berman and others, go back and listen to those. But so you're part of the Tallwood team. What's your role there as an engineer?
Yeah, I guess I think in totality, I guess I'll speak a little bit about what I think the practicing engineer's role is in research more generally, and then I'll take it down to sort of how I've been involved in Tallwood. People like to use analogies a bit, and I think the often when you hear about this research to practice transition is sort of a relay race, right? Where the academic or research team runs for a bit, hands off the baton to practicing engineers, and they run for a bit, and then maybe it comes full circle and they pass it back to a researcher, and it goes in this loop. And I think to a degree that analogy is flawed in that research isn't really a race. It's not it's not a sprint. People say it's a sprint, it's a marathon. It's neither of those. It's not even really competition. It's collaboration. And so I was trying to think of what's a better analogy to
it's like describe. Dungeons and Dragons. Right, like you're playing against the game.
Yeah, right. And so that gives a little bit about your proclivities and mine. You can't see below, thankfully, below my head very well. But for me, it's all about food. So what I thought is, this collaboration between a practicing engineer and researchers is really about it's like making a meal together, right?
Yes.
And so you can you're creating something that's it's useful, like it feeds you, but it also creates something completely new. And you're only really doing it when you're doing it together. You're creating something that's more than some of its parts. And I like to think of it as working together, working at the same time produces better results. It's food's also a way that brings people together, and I think research can be that too. And it just kind of has to have, as with everything, the right people and sort of the right mindset. And I think, the term I like to use where I like to get involved is what I call applied research, right? So I think there's a purpose and a place for sort of direct fundamental research. And not to say anything bad about that, but it's just not something that I can feel like I can contribute as well to. And in this sort of applied research space, as I like to refer to it as, I feel like there's a lot of opportunity for practice engineers to bring something to the table. Like you said, maybe they're bringing the vegetable, or maybe they're bringing the meat and to the table. And really, when we can basically able to make something together, and that applied research space is kind of very fruitful. Again, to keep the analogy going. Yeah, there's a lot of interesting things to solve in that space, and I think by moving forward together within that space, amazing things can happen.
Yeah, and I think like any good potluck, right? There's challenges of logistics.
Sure,
there's opportunities for innovation and collaboration. What have been those some of those moments for you as you've been going along this Tallwood journey for the past few years?
Yeah, I think great question. I think there's always this idea that when you have a practicing engineer, they're just going to be the person there telling you like, hey, this isn't practical. This isn't practical. This isn't practical. But I think the vision really is that not that you can't. I mean, it's very important, right, to explore the research space, right? So you should have, I think, someone on the team, or it's helpful to have someone on the team thinking about where this might eventually go. But it's not always important to take the shortest path to that direct practice, right? Like sometimes when you're exploring the space, someone who has 1 foot or a foot and a half in practice is going to say, wait a second, that's actually like maybe as impactful as what we were originally thinking this could go towards. Why don't we explore that as basically a path to practice too? So it doesn't have to be sort of this linear line directly to.
So it sounds like your role is not unlike like engineer to someone who's actually building something, but you're more like the person who's actually building something to an engineer as your role to a scientist, right? It's not to like to dissuade or to stop people from pursuing their research question, but it's to say, okay, what's the most effective for our overall goals of this project, given how real things really work?
Yeah, and like I think the example for Tallwood would be like when I came in, and I felt like one of my contributions was to say like, hey, we need to like let's make sure we focus this 10-story test and very much being a research objective, but let's focus it also on having a design aspect, right? Like not take it, making the distinction between what is design of the 10-story test versus what is response prediction of the 10-story test. And obviously response prediction can backfeed into design, but like if you just start towards, well, we know, high, very, very specific criteria we want to meet, and we can just do a bunch of response prediction and sort of design by analysis. And I came to it and said, well, the way we would approach this in practice is we would establish a design based on some fundamental principles and proportioning. And then we would use response prediction, maybe not to the level of detail that has been done for the 10-story test, but we would use response prediction to help inform that design. And so I felt like what we did with the 10-story test was very along those lines. And as a result, even though it is a test specimen, it has a lot of the same aspects in its development as a real building would.
Yeah, and then you get to answer questions like, well, how would someone go about constructing and managing a construction project like this for a real building, which gets to our second half of our questions here of what is some of your vision as an engineer for incorporating some of these innovations coming out of Tallwood into real buildings? Like where are you seeing some progress, and what are some challenges, some future research questions?
Yeah, right. Yeah, so let's stay positive. We won't start with the challenges. We'll start with sort of what I see some of these innovations where they might translate to in practice. I think right now there's this great how do you say it? Sort of like there's this great like intersection of two movements happening. The mass timber movement, which sort of started in the Pacific Northwest, but I guess in the U.S. has started in the Pacific Northwest, but really started in Europe, and has grown to be nationwide, and obviously transcends borders. And the embodied carbon, global warming potential, and I'd even throw resilience into kind of in these movements, they dovetail quite well. They're very synergistic. I think that's really where I see the progress, the likelihood of this sort of all of us coming together, sort of what's the saying? Rising tide lifts all ships.
Raises all boats.
Yeah, raises all boats. Yeah, exactly. I think that if we can recognize the co-benefits of a resilient seismic force resisting system, building out of wood for aesthetics and the human experience in the buildings, and the benefit to our climate and to potential climate collapse. I think that's really powerful, and that's my, I guess I would say, that's my sliver of optimism. I'm not generally fully an optimistic person, but that's my sliver of optimism that we can kind of see many of these movements come together toward a common goal.
Yeah, it's in this space. It's good to be an optimistic realist, right?
Yes, exactly.
Have hope for the future, yes. Grounded in reality.
Yes, grounded in reality. Absolutely. I think the thing that engineers to a degree, and we'll just skim right close to what some of the challenges are, but engineers have a lot of limitations put in front of us, right, when we're doing design for real building projects. And we have a sort of like, I won't say, the common analogy, we use another analogy, is tools in the tool belt, right? And I'll say, okay, here's me going back to my same analogy over again, but I think it's more about it's about spices, right? What spices you have available to you.
There you go.
And right now, some of those spices are on the top shelf, right? They are out of reach for a lot of engineers. They're out of reach for a lot of owners. Really, they're accessed through performance-based design, right? If you need to use a mass timber rocking wall system right now, you're going down the path of performance-based design, which has great applications, it works, but it's for the few, right? It's not for the masses. And so what I'd like to see, and what I'm encouraged to see with the innovations coming out of Tallwood research, is how we can take that, basically the use or application of a mass timber rock and roll building, and bring it to everyone, in a way so we can start to see real buildings built this way and for the right application, right? This is not the seismic force resisting system to end all seismic force resisting systems.
Yes,
it's just one that we need to have available to us. For the right application, I think that we can do that through a lot of the work that's being done with the 10-story test.
Yeah, it's especially encouraging to see. I mean, now that we live in the Pacific Northwest, when Tallwood started, I lived in Indiana, which was really interesting. But now it's staring you in the face, yes, living in Eugene, we probably won't be as impacted by the big one as other areas of the Pacific Northwest will be. But it's on my mind, right? Of wow, our little house here, if it were closer to the coast, we'd be in real trouble, and would be looking actively at these seismic retrofits that are coming out of things like Tallwood, things like the Tallwood Design Institute writ large, which if you're interested in this at all listening, check out the resources there at TDI. And their conference is excellent and very affordable. I mean, we just drove up to Corvallis, and there's a couple $100. It's not a insurmountable way to rub elbows with the leading people who are doing the research and putting it into practice of mass timber, and see how it's going to apply to places like your neighborhood or the architecture of a elevated structure in your city. In the not too distant future. It's really cool.
I think, you bring up great points, and that's what I was maybe not doing as well to say earlier, is that
this is why I'm here.
A lot of times we have these, on projects, their demand, they're like visioning, as part of the visioning exercise, we have objectives, and a lot of times those objectives begin to compete against each other. So resilience and sustainability, right, can often compete against each other. What I see the real advantage of the Tallwood research is that we can basically turn those from being working against each other to working with each other, right? So that there's something that is good for is less bad for the climate, can be resilient and sustainable kind of all at the same time.
And that's even more power. So good for us as humans on a psychological level, right? Like being around beautiful design with natural materials, in our field of vision is just good for our, us sociologically and mentally too.
Absolutely. I mean, like during this was my pandemic background that you're seeing behind me, and I'm not sure this was the thing that got me through it. Maybe it was alcohol, but it was one of the two that like made me, being around wood is a calming experience, and that shouldn't be downplayed.
Yeah, and any way we can make it more available to more people through building apartment buildings that are seismically resilient, sustainable, beautiful, awesome, or building furniture out of the offcuts from those, like one of our colleagues at the University of Oregon is doing. It's so cool. So anyway, it's amazing to see some of these applications from this building project that are going to be coming out for decades. We've got great ways of reusing that data and seeing it come along. So really, really excited to explore this. And thanks for coming today, Reid. It's been great to get a little bit of your perspective, and hopefully I'll see you down in San Diego in March if all goes well.
Yes,
knocking on all the wood we have available here.
Literally knocking on wood. Yes, it doesn't hurt that the test is happening in San Diego in the spring in the Pacific Northwest. Gives a good excuse to escape the rain for a few days.
Boy, do we need some sun, as I am experiencing some for once. But yes, so thanks so much, Reid, and we'll hopefully see you down in San Diego in the not too distant future. Thank you so much for listening to this episode of Design Safe Radio. We really appreciate it. Smash that like button if you're watching this on YouTube. Hit that little subscribe button. That really helps us out and bring this message to more people who are interested in hearing about how our engineers and scientists are making our society more resilient to everything nature throws at us. A big thank you to our sponsors at the National Science Foundation. Our award number is 212-9782. And a big thank you to our program officer, Joy Kowski, who is excellent. And our team at the National Science Foundation's Network Coordination Office for NHERI. Marty LaChance is our question writer and copy editor extraordinaire. Raquel Ruiz manages all things technical and editorial. And Morgan Glass is our social media coordinator. Big thank you to everybody at the NHERI NCO and all of our experimental facilities. Thank you and have a great day.